I don't want to be ashamed by the things I don't know. Because there is a reason why I don't know those things. And the reason is because they are not transparent. If they say, okay, but this is not wrong, I say, okay.
Tell me.
Tell me how it is.
In een wereld vol schaduwkanten richten wij het licht op mensen en verhalen die ons leiden naar sporen van de toekomst. Dit is Tegenlicht. Welkom in de wereld van AI. AI, of in goed Nederlands kunstmatige intelligentie, is hot.
When we think of AI, we think of this benevolent, all-knowing, God-like machine that just, works by magic.
De komst van AI wordt zelfs vergeleken met de uitvinding van de stoommachine, elektriciteit of het internet.
I would use it so I can create a digital copy of myself, or like a digital clone that sounds like me, thinks like me, hopefully. I mean, maybe.
I think there is too much trust in a technology that we don't understand.
Tegenlicht maakt zichtbaar wat er allemaal voor nodig is om deze nieuwe technologie te voeden en draaiende te houden. Om AI voor ons te laten werken. Wat zijn de ware kosten van deze zich razendsnel ontrollende revolutie? Kosten die Silicon Valley liever voor ons verborgen houdt. Dit is de skyline van Novi Sad, een universiteitsstad in Servië. Een stad waar de littekens van de Balkanoorlog, die er eind vorige eeuw woedden, nog altijd zichtbaar zijn. Dit is de skyline van Novi Sad, volgens een door AI aangestuurd programma. In woorden voer je een omschrijving in van het beeld dat je voor ogen hebt. Een zogenaamde prompt. En de AI berekent. Voilà. 4 verschillende skylines van Novi Sad. Een stad met een brede rivier en verschillende bruggen. En dit? Dit is de echte skyline van Novi Sad. Hier woont een man die zichzelf een kritische cartograaf noemt. Hij maakt kaarten van dingen waar geen kaarten van bestaan.
I became really obsessed with materiality and anatomies of what they present to be an AI. I really like to think about what's behind.
Okay, this is anatomy of an AI.
So I'm not so interested in what we can do with it and how the interface looks like and how it's created. I'm interested in what's going on behind. So how it's made. So this one is called Anatomy of an AI System, and I did this one together with Kate Crawford. It has 3 parts. So this is the birth, this is life, and this is death.
Met deze kaart heeft hij geprobeerd duidelijk te maken welke systemen op planetaire schaal er in werking worden gezet wanneer je een AI gebruikt. Of dit nu een smart speaker, een routeplanner of het nu populaire ChatGPT is.
So basically what we were doing for back then 5-6 years, it's just this line. No? So this is you as an user. No? So we are following basically how the information is flowing through the infrastructure and going here and then coming back and then going back here. And this is all happening in 1 second or less than 1 second. And because it's so fast, we don't question all of these things. So this is like,
if you turn on the light with your Google Home or
exactly,
Nest,
information goes from here to I don't know, West Virginia. It comes back because you were so lazy to stand up and to turn on the light. But you activate the planetary scale system to do that instead of you. No? But it's a different dimensions of different planetary scale systems. It's not just one. From there, it goes into many different directions. It goes in direction of death on one side, or on this side, it goes into the birth.
Want om al onze AI te laten functioneren, zijn er om te beginnen mineralen en metalen nodig.
So each of those elements are basically, like story of lithium.
or silicone.
Silicon, or like whatever, some rare earth elements. And each of them, if you follow, each of them, it's a completely like a festival of craziness that is happening to them. Mines, smelters, refiners, component manufacturers, assemblers, distributors, really simplified. But there is like thousands or tens of thousands of companies participating, from like the mine in Congo to the Foxconn in Shenzhen. So it's like constant flow of metals, components, labor as well.
Al die grondstoffen worden uiteindelijk niet alleen gebruikt om smartphones te maken, maar ook om een wereldwijd netwerk van glasvezelkabels en datacenters aan te leggen.
Inside of those data centers, you have algorithms, no?
Algoritmes die supersnelle chips nodig hebben.
To train this network, to have hundreds and hundreds of GPU's or processor power. And
chips die hard nodig zijn, omdat de nieuwste AI veel meer rekenkracht nodig heeft om de berekeningen uit te voeren.
Then behind this, you needed to have some human beings training those algorithms. You have human beings labeling those algorithms. And this is all, most of the time, done by some kind of like invisible labor. This is completely like not part of our conscious, let's say.
So is this the cloud, in a way?
This is the cloud, yeah, in some strange way. Some really hardcore cloud made of sweat, blood, and metal. And it's just not possible to visualize. Because, this is probably in there. Okay.
Silicon Valley gebruikt voor al die algoritmen, chips en datacenters graag het woord the cloud. Luchtiger kan het bijna niet. Het is in deze wolk dat we een AI een opdracht geven. En waar het voelt alsof de uitkomst als het ware uit de lucht komt vallen.
What they call AI is basically a statistical model that is taking everything, every piece of information that they feed into it, and then creating a statistical model out of it. So it doesn't know anything. It doesn't. There is no any kind of, cognition in that sense. It's basically just statistical reflection of the data that is within the dataset.
Wat zou er gebeuren wanneer we datgene wat Silicon Valley graag verborgen houdt in beeld gaan brengen met de door hen zelf ontwikkelde AI-modellen? Laten we beginnen bij de chips. Om algoritmes te kunnen laten rekenen zijn er computerchips nodig. Een belangrijke grondstof om die te kunnen maken is silicium, zand in hele fijne vorm. En daarvan wordt 70% van de mondiale productie in China gewonnen. Dit zijn geen foto's van mijne, maar de uitkomst van een statistisch model, een AI, dat berekent hoe een mijn voor silicium in de Chinese provincie Xinjiang eruit ziet. Toegang krijgen tot zo'n mijn in China is zo goed als onmogelijk. Maar gelukkig kan de AI ons wel laten zien wie de mensen zijn die het silicium naar boven halen. Ik herhaal nog maar even, deze mijnwerkers bestaan niet echt. Het zijn statistische berekeningen van hoe zo'n mijnwerker eruit ziet. Volgens internationaal onderzoek worden er bij de winning van silicium ook Oeigoerse dwangarbeiders ingezet. Zij worden uit het zicht gehouden in afgelegen interneringskampen. Maar de AI genereert ze moeiteloos. Hoe kan het dat de AI een beeld heeft van alles wat je het maar vraagt?
The first step is creating this like a huge amount of data that is becoming this training data set. Then the second step usually is labeling. When we have like face recognition or like let's say tree recognition system in which we feed like thousands and thousands of images of trees, then some human beings need to label each of those images and say, this is the tree, this is not a tree, this is this type of tree or whatever. So this is like a invisible human labor. And this is like really super intensive job. So basically what we are doing, we now have like thousands and thousands of images of trees. And now we are compressing this into the statistical model of the trees. So it's not anymore images. Now it's some kind of multidimensional statistical space. And it's like really nice word to explain this, like hallucinating. And so those are statistical hallucinations. It is really important what is going on within the data set. What kind of pictures or images or sounds are being part of the data set, because this will be reflected to the world as a rule, as an automatized process.
Silicon Valley is dus op zoek naar datasets. Je kunt zelfs van een race spreken naar de grootst mogelijke dataset. Maar uit welke data bestaan die dan? Als een van de weinigen doet Abeba Birhani aan de Trinity College in Dublin onderzoek naar wat nu precies de inhoud van die datasets is. Dit doet ze door de data te auditen, ofwel op kwaliteit te controleren.
People would spend a lot of time, in collecting the data, for example, putting aside resources to label the data, and doing various tasks to detoxify the data, to improve the data. But now, over the past 2 years, all that is gone. The way datasets are created is not through human curation, but they use automated systems to collect datasets, mainly from the common crawl.
AI-programmeurs ontdekten dat er met grotere datasets interessantere en slimmere uitkomsten gegenereerd konden worden. En zijn daarom massaal overgestapt op gigantische, automatisch verzamelde datasets, zoals die van de Common Crawl.
You find really, deeply ingrained stereotypes represented in datasets. So, for example, when you type beautiful, you get a lot of, the dataset returns a lot of naked women, a lot of the images coming from pornographic sites. Whereas when you query the dataset with the word handsome, you find, white men in suits, looking very respectable. For example, here is the result for the prompt schoolgirl, and then you can then compare it with a schoolboy. And you can see if there is any difference. As you can see here, for schoolgirl, there is a lot of sexualized content. And we can type schoolboy and see what comes up. I don't see any image that is of sexual nature.
Have you tried to prompt a woman from Ethiopia?
I haven't, but I have prompted Ethiopia, of course, because I'm Ethiopian. I am interested in how Ethiopia is represented. When you train AI systems based on these data that are, stereotypical, the model learns about Ethiopia, for example, from these stereotyping images.
En als we de AI deze opdracht geven, dan is dit het resultaat.
This is not a true representation of Africa. This is, Western white people's perception and representation of what Africa is like. So this is the problem with internet-sourced datasets.
We are going towards, something that is average, something that's statistical progression, and we are losing all of those fine grains. And then again, if we think about culture and like society, what is fine grain? We are fine grain. We are fine grain as an artist, as a like everyone that is different is a fine grain. And those systems are statistical systems that are leaning towards the, some kind of like statistical mediocrity.
Iedere dag lijkt er wel weer een nieuwe AI-toepassing uit te komen. De econoom Tamai Beziroglu, werkzaam aan het gerenommeerde technologie-instituut MIT in Cambridge, maar nu even op bezoek in Rotterdam, probeert te berekenen wat er voor een mogelijk volgend AI-model allemaal nodig is. Zijn onderzoek wordt nauwlettend in de gaten gehouden door Silicon Valley.
Since the field of AI, kind of got started, we have been scaling up the amount of computation to train these systems, doubling it every 18 months. In recent years, the amount of computation has been doubling every 6 months, which is much faster than we've seen historically. We've also seen companies accelerate the amount of money that they're spending on this.
And what does one chip cost?
One chip costs about $10,000. Yeah. I mean, they might get discounts and sometimes it's kind of unclear, but on the order of $10,000, and they use about 25,000 of them, so that costs about $250 million if you were to buy it kind of outright.
Just for this one model to work?
Yeah, that's right.
Wat is er dan precies allemaal nodig voor de volgende generaties AI? Zoals ChatGPT 5 en 6 en 7?
We know that between every GPT, there's been about 100x increase in the amount of computation. Increasing the computation by 100x roughly costs them 100x more. I suspect that would place the dollar costs in the many hundreds of millions of dollars. There aren't many players that can afford this.
And this is the super important question. It's like, who is able to create that? Because if we go back again to all of this, we can ask, who is owner of the tool? No? To whom these tools are belonging? Because the one who is owner of the tool of production will be basically the one who will rule the game after.
What the model actually learns during training is something that is very opaque. And so we are kind of in the dark about actually what happens inside these models. even the people who are writing the code that train these models.
Should I look straight into the camera?
Zonder dat de AI-programmeurs precies weten wat er zich in de black box afspeelt, is er om te kunnen groeien geen andere weg dan nog meer data verzamelen.
So these models, like GPT-4, use on the order of 1 trillion words that they kind of see during training.
A trillion words.
Right, yeah.
Where did they get a trillion?
So they get this from books and Wikipedia pages and things like high-quality news sources, scientific publications that are important. On the other hand of the spectrum, you have kind of text that you find on large internet platforms and forums and so on, like Reddit. But maybe in 5 years we will have gathered, or these companies will have gathered a very large fraction of the total data that humans have produced that kind of exists, that like humanity has generated as a collective. I would not be surprised if training models on outputs of machine learning models would be an okay substitute for the quality of the text that's generated by humans.
If we don't find a solution how to deal with that, in 1, 2, 3 years, we are going to be completely polluted by the content that is artificially generated. In theory, in few years, there will be more artificially generated content than the human-generated content. And that's completely crazy again. It's a now statistical system who is made to create bullshit. So we have basically automation of this information. And then from the same companies, we are expecting that they will find a way how, again, to automatize what is true, what is not true. So we are now have like a two different, we expect from them to create like two different synthetic automized system, one that will produce the knowledge and one that will correct the knowledge. And it can go wrong in so many ways.